Okay, we are starting in Chapter 5. This is 5.1 today, hopefully. 5.1. And we are talking about polynomials. All right, when we talk about polynomials, polynomials are terms separated by addition and subtraction signs. Or subtraction signs. A polynomial also has a form that's called standard form. And it follows two things in its standard form. A polynomial standard form, its exponents are in descending order. And the second rule that it follows for standard form is that the variables are in alphabetical order. All right, so an example of a polynomial might be 5x to the 5th plus 4x to the 4th minus 2x to the 3rd plus 7x squared minus 9x plus 1. You'll notice those exponents are in descending order. That is standard form. Means going down. So you start at the highest and you go down. So that's why it goes 5, 4, 3, 2, 1, 0. Okay?
Wait, what's that?
All right, so the first thing we're going to start with is these polynomials can be classified. So we're going to talk about classifying polynomials. When we classify polynomials, they follow two things. One, we classify it by degree, and the second is its number of terms. So let's talk about some of those special words we have. If the degree of the polynomial, the highest degree of the polynomial, is 0, the word for that is constant. If you have the highest degree is 1, or x to the first power, we call that linear. If we have something to the second power, which was our last or previous chapter, that is called quadratic. If we have something to the third power, or your highest degree is 3, that would be cubic. No. If you have something to the fourth power, we call that quartic. If your highest degree is 5, like the example I just did, that would be quintic. And then anything greater than an exponent of 5, it's called that degree. Number degree. So that's the first word we use to classify it. The second one has to do with the number of terms. So obviously if we have 0 terms, that's not anything, right? But if I have 1 term, that is called a monomial. If I have 2 terms, we call that a binomial. If I have 3 terms, it is a trinomial. Yes. And then anything greater than a trinomial, we call it a polynomial of that number of terms. Now to classify it, the first thing you have to do is make sure it's in standard form, okay, so that you can tell what's going on. So here is example number 1. Example 1, I'm going to ask you to classify. And let's say I have 7x to the 4th plus 2x to the 3rd minus 9. My highest exponent is a 4. This is in standard form already. All right, my highest exponent is a 4. What is the word for 4th degree? Quartic. Very good. Quartic. Then we look at the number of terms. There are 1, 2, 3 terms. So that is a trinomial. Yep. All right, what if I had 3, yes, I'm the same one. 3x to the 5th plus 2. So my highest exponent, yes. Yes, it is a quintic binomial. All right, let's go with example number 2. Example 2. Yes. For example number 2, this is going to be your 8 through 18. Through 18, first, write in standard form. Then classify. Again, this is all you're doing for 8 through 18. So maybe you have 2m to the 3rd plus 7 minus 5m to the 5th minus 2m squared. All right, to put it in standard form, we do it in descending order. So we start with the highest exponent. And remember, the sign always goes with the term. So our highest exponent is this 5 here. So the term that comes first is negative 5m to the 5th. Then what would come next? Good. Positive 2m to the 3rd. Then, good, minus 2m to the 2nd, and then plus 7. Now that it's in standard form, we have to classify. Yes, quintic, polynomial of 4 terms. Right. Yep. All right, let's do one more underneath the same example very quickly. Let's say I have 3x to the 3rd plus 2x squared minus 5x to the 3rd plus 2x to the 3rd. First, we put it in standard form. You start with the highest degree. Yeah, we have 3x to the 3rd minus 5x to the 3rd plus 2x to the 3rd. Okay. Listen. Yes. Okay, hold on. I agree with Ethan, okay? We have to combine like terms, and we start with the highest degree. So if I have 3x to the 3rd minus 5x to the 3rd plus 2x to the 3rd, combining those together give me 0x to the 3rd, so there aren't any. They all canceled out. So all I have left in my standard form is 2x squared. Now we're going to classify that. Squared is quadratic, and it is only one term, so it's a monomial. Is there any question what you do 8 through 18? Okay. All right, next thing I want to talk about is graphs of polynomials. All right, graphs of polynomials. So very quickly, I want to talk about if I have something that is linear. That graph makes a line, right? And of course, that would be like y equals x or 3x or 4x or whatever. If I have something that is quadratic, like y equals x squared, what shape does that make? A U, a parabola, right? A U. If I have a polynomial that's cubic, or y equals x to the third, what does that one look like? No? It's kind of like that S curve. I always talk about the S curve. It does one of these deals. Okay. Okay? If I have a quartic, or y equals x to the fourth, that kind of makes a W shape. All right, so now looking at the graphs I have up there, I want to talk about their end behavior. What do you notice about their ends?
They're straight. They don't end.
Okay.
Look at the exponents.
What do you...
They equal one less than...
That's the tens, my one, the end.
Yeah. We're talking about the end behavior. So on the left-hand side, I have polynomials that are odd, linear and cubic. What do you notice about the way they're pointing? Yes. Yes, they're going in opposite directions. On the right-hand side, we have the even ones, squared and x to the fourth, and they're both going the same direction. All right, so here's what we're going to do. I'm going to make you a little table here. All right, so I'm going to just do this kind of like a little box table. Up here, I'm going to put odd and even. Over here, I'm going to put a positive and a negative. If you have a polynomial function that is odd and positive, so your leading coefficient is positive, your end behavior will be down, up. So left is down, right is up. If you have something that is odd but negative, its end behavior would be up, down. It's going to flip. If I have a polynomial who's got an even exponent and it's positive, that is up, up. And if it is even and negative, it is down, down. Exactly. All right, this is all end behavior. This is what we're going to use this year for end behavior. All right, so here is example number 3, which will cover 20 through 30. Describe the end behavior of the polynomial function. So let's say I have y equals 3x to the third plus 2x squared minus 7x minus 10. I want to know the end behavior. So I look at my highest exponent, that is odd, and my leading coefficient is positive. So this is odd, positive, so the end behavior would be down, up. That's all you have to write is down, up. Say I have y equals negative 4x to the fourth plus 3x to the third minus 2x squared. In this one, the first thing I look at is the exponent. My exponent, is it even or odd? Even. And is my leading coefficient positive or negative?
Negative.
All right, so even and negative. Down, down.
Down, down.
All right, so this is all you have to do is look at your highest exponent and the coefficient on that, okay? Make sure it's in standard form when you do it, okay? If for some reason you don't remember or you're not sure, what can you do with that awesome yellow thing you have in front of you? Graph it and look at it. What's happening on the left and what's happening on the right? Okay? Super easy. All right, are we good here? Okay. We're getting there. We're getting there. There's some to go, yes. All right, I want to talk about increasing and decreasing intervals. When I say increasing and decreasing intervals, I am talking about what is happening referring to x. So you always use x. You go from left to right as you draw. As you draw. So what I mean is, let's say I have a graph. Here's my graph. All right. There's my graph. Now, if I were going to draw this, the first thing I do is I start up here and I draw going down. Well, if I'm drawing going down first, that means my first interval is decreasing. When I say decreasing, I like to refer to using a arrow. So I'm going to say it's decreasing from negative infinity to my x value of negative 3. Make sure you're writing this down. Then, from here, if I was drawing it, I would draw it going up. So that would mean that I was increasing from negative 3 to infinity. I'm looking at the x value is what I'm referring to. It's like reading across like a book, whatever the x value is. All right. That's it. Not yet. This is getting you ready for 30 through 36. Okay? No. And last one. Let's keep going. Call that negative 2. Positive 2. All right. Okay. So now, if I wanted to talk about the intervals here of increasing and decreasing, what am I doing first? As I draw it, I am decreasing to this point. And what is the x value at that point? Right. So I'm decreasing, so I can draw an arrow pointing down, from negative infinity to negative 2. Then, as I continue drawing, I'm now drawing up to here. What is the x value as I draw up to there? 0. So I go from negative 2 to 0 is where I'm increasing. Then, as I continue drawing, I'm drawing down again, or decreasing to where x equals 2. So I draw an arrow down, going from 0 to 2. And then the last interval, right? I am increasing. So I draw my arrow up from 2 to what? Infinity, exactly. So this should always start with negative infinity and finish at positive infinity. Okay? All right. But you're going from 0 to 2. Well, how am I drawing it? Right? I'm going down, aren't I? Yes, but you're using the number from the x-axis, but where the arrow's going is how you're drawing it. Okay? All right. So then I'm on example what? 4. Example 4. This will cover your 32 through 36. All right. And in this section, I want you to describe the shape of the cubic function, including end behavior, turning points, and increasing and decreasing intervals. All right, so here is my cubic function. First of all, what is our end behavior? Up, down. I agree. Up, down. Okay? How many times does this turn? Turns twice. So we just have 2 for our turning point. Now we've got to decide on our intervals of increasing and decreasing. So as I start to draw this, am I increasing or decreasing? Decreasing from negative infinity to what is my x value where I'm decreasing? -3, very good. Then from -3, what am I doing? Increasing from -3 to where? 0, right? I'm increasing only to here. So then after 0, what do I do next? Decrease from 0 to, where is this? It goes to infinity. No? Remember, it's on the x-axis. It starts at negative infinity over here, and it finishes at positive infinity over here. It's reading across like a number line, like a book, left to right. Okay? So you have 3 of those to do. Last problem. That all depends how big you write. You can use that. Here's example number 5. This is going to cover your number 38. Determine the degree of the polynomial. Now, you did this back in Algebra 1. So, we're going to discuss it. Make sure we still remember it from Algebra 1. So I'm going to give you a table. In my table, I have the point -2, -15. I have the point -1, -9. I have the point 0, -9. I have the point 1, -9. And I have the point 2 and -3. In order to determine its degree, we have to do, back in algebra, I called it the loops. You have to do subtraction, the difference. So you take the second y and subtract the first. So -9 minus a -15. -9 minus a -15. Is -9 plus 15 or? It's 6. Thank you. Okay? Then we do the next one. Negative 9 minus a negative 9. Yes, that would be 0. A negative 9 minus a negative 9 is 0. Negative 3 minus a negative 9. Negative 3 minus a negative 9. This is a sandwich, so we get positive 6.
So it's a cubic, right?
No. Well, hold on. How do you know that?
I was just thinking, because, like, if you think about the shape, it goes like that.
Okay, but you don't. We need to keep going. That's not the point, okay? If all of these loops match this first time, it would be linear. If they don't match, we do it again. Okay? So, 0 minus 6 is negative 6. 0 minus 0 is 0. 6 minus 0 is 6. If they match this time, it would be quadratic. It would be x to the second power. But they don't match. So then we have to do it again. 0 minus a negative 6 is positive 6, right? 6 minus 0 is 6. Now that they match, we count the number of sets of loops we had to do. We had to do 3 sets of loops. So this is cubic, or x to the third power. All right? You have to get to where they match. I need to see this work. Okay? All right. Any questions? All right. We still have 10 minutes. I'd love to see you guys get started on classification so I can answer questions. Yeah.